Okay, we just took a look at exponent laws. Now we want to work with them a little more. So, for example, we saw that if we have a multiplication with the same base, we can simply add the exponents. Now my exponents are a variable and a number, and that is my answer. So working with variables will be extremely similar to working with numbers. So let's say, for example, I have 6 to the x over 6. Again, if I don't see anything, I'm always going to remind myself to put in an exponent of 1. So I am dividing with the same base. I'm simply going to subtract the exponents. Now, if I have exponents to exponents, again, I'm going to simply multiply the exponents. Now, that is going to be extremely useful. I'm just going to do this one again, a tad different. 5 to the x squared equals, again, 5 to the 2x. Simply multiplying my exponents with the exponents at different locations, we get the same answer. Now, what about something like this? Well, again, if I don't see anything, I'm going to give an exponent of 1. Then I am simply going to subtract the exponents. It looks odd, but that's the rule, and we're going to leave it like that. So now we're going to reverse the process. If I see something like 6 to the x plus 1, we want to very easily be able to say, well, I just added my exponents. I should be able to separate this into a multiplication. And for example, I can bring this 6 out in front. So as you can see, we had no problem going this way on the last page. We should absolutely be able to go this direction, separating exponents. Again, we're going to use these rules interchangeably very fast. So the idea is to really understand getting to know the basics of these rules. So let's say I have 7 to the x minus 1. Well, that's 7 to the x over 7 to the 1. Again, we had no problem going this direction, so now we have to be able to go this direction, no problem. Let's say I have something like 4 to the 1 minus x. Well, that 4, the 1 is a positive, so one that goes on the top. Now negative x is a exponent that will be going on the bottom. Interesting. How are we going to use that in the future? Not exactly sure. What if we have something like 3 to the 2x plus 1? Well, we know, for example, that is 3 to the 2x times 3 to the 1. Now, this is interesting what I'm going to do next. So I know that, I'm going to go down the page for this one. I know that 3 is going to go in front, and then I can simply write 3 to the 2x. I'm going to leave that 3 in front. Now, I could make an interesting move like this. 3 to the x all squared. And that is the answer there. Lots of the times we want to isolate for something to the x for some purpose. And one of the last rules that we'll do on this page is something like 6 to the x. Well, I know 6 is simply 2 times 3. Still to the x. Well, now I can give each thing an exponent of 1, and I can give that exponent to both things for 2 to the x times 3 to the x. Now, why do we want to do that? Not exactly sure. These are just the basic rules that we're going to be going over very carefully. Get to know all these basic rules, and then it's going to be a lot easier doing the more complicated problems. Now let's take a look at a little bit more complicated fraction. 2 to the 7x plus 5. Then we have times 8 to the x plus 1 all over 4 to the x minus 2. So the first thing I want to think is 2, 8, and 4 all have the same base. What is it? It's 2. So 2 doesn't change. Now 8 is 2 cubed. And 4 is 2 squared. Now I can multiply all the exponents together. So I have 2 to the 7x plus 5 times. Now, this is a little bit more complicated. I'm going to take the thing that looks funny off to the right. So I have 2 cubed to the x plus 1. And I know that I'm going to multiply the exponents. And I'm doing this away from it to be very simple. So I have 2 to the 3 times x is 3x. And 3 times 1 is 3. Then I'm going to take that answer and I'm going to bring it back into the question. So times 2 to the 3x plus 3. I make a lot of mistakes when working in the equation, so it's really helpful to bring that thing off to the right, work on it all by itself, look at it clean, and then bring it back in. So I'm going to do the same thing with the exponents on the bottom. So I have 2 squared to the x minus 2. So I'm going to multiply the exponents. So I have 2 to the 2x minus 4. And then I can simply put that on the bottom of the fraction where I was working. So on the top, I simply add the exponents. So that's going to be relatively simple. Notice I have a fraction. I start off with the fraction right away. So I'm simply just going to add the exponents. So 2 to the 7x plus 3x is 10x. And 5 plus 3 is 8. Now, if that was a difficult calculation, I would have done it off to the right. I'm simply going to leave what I have on the bottom. Now, I'm going to be subtracting this from this. Now, that is going to be way more complicated. I'm going to do that off to the right. So we have 10 to the exponent x. Excuse me. We have 10x plus 8 minus 2x minus 4. Now I'm going to distribute this negative, so in. So we have 10x plus 8 minus 2x plus 4. So 10x minus 2x is 8x, and 8 plus 4 is positive 12, so I can simply say 2 to the 8x plus 12. Perfect. Okay, that is finished with the basics. Now we're going to work on some more complicated equations.